Imagine standing under a night sky so dark and clear that the stars look almost close enough to touch. They glitter and burn in silence, each one a distant sun, each one carrying with it the possibility of unknown worlds. For most of us, the night sky feels unchanging. The constellations return season after season, as though frozen in place. But sometimes, if you look closely, something new appears. Something small, almost fragile, yet carrying a secret from across the galaxy. This is how humanity first noticed 3I/Atlas. Not with a blinding flash or a thunderous warning, but as a faint point of light recorded by an automated telescope in Chile. It was July 2025, and the Atlas survey, a project designed to scan the sky for moving objects, picked up a speck shifting against the backdrop of stars. At first, it looked like many other faint wanderers catalogued each week, but when astronomers calculated its path, the data told a different story. Its orbit was not a loop, it was not bound to the sun at all. Instead, the numbers revealed something startling. This object was just passing through. It had come from beyond the solar system. To appreciate how rare this is, it helps to remember the scale of our neighborhood in space. The solar system is vast, stretching billions of kilometers from the sun to the outer edges, where comets linger. Beyond that, the gulf to the nearest star is almost unimaginably wide. Most of the asteroids and comets we see belong to the sun, circling it like bees around a hive. They may travel far, but eventually they return. An interstellar visitor, on the other hand, is like a stranger, appearing in a village where everyone else is family. It does not belong, and it will not stay. For most of human history, we had no proof that such visitors even existed. It was only in 2017 that the first one was recognized. An oddly shaped object named Oumuamua. Its path told us it had come from elsewhere, but its form was so strange that debate raged about whether it was a comet, an asteroid, or something entirely new. Just 2 years later, another appeared, 2I/Borisov, which looked more like the comets we already knew, but still carried the signature of a foreign origin. And then, in 2025, 3I/Atlas arrived, the third such object ever seen. 3 interstellar travelers in less than a decade might sound like many, but in cosmic terms, it is astonishing. For billions of years, objects like this have likely crossed our skies unnoticed. Only now, with sensitive telescopes and worldwide coordination, can we detect them. To glimpse 3 in quick succession is not a sign that the universe has changed, but rather that our eyes have finally opened wide enough to see. The discovery itself unfolded quietly. Astronomers working with Atlas noticed the unusual trajectory and sent alerts across the global network that tracks potential threats. Soon, observatories on different continents turned their instruments toward the speck. Its motion confirmed the truth. The eccentricity of its orbit, the measure of how stretched out the path is, was greater than 1. In simple terms, that number marked it as unbound, a visitor that would not circle back, but continue on its way. Numbers alone can feel abstract, so imagine this. If 3I/Atlas were a ball thrown past the sun, it would not slow down and curve back. Instead, it would fly past, tugged only slightly by gravity, and then continue outward forever. That is what makes it different from the billions of icy rocks that live in the distant Oort cloud or circle in the asteroid belt. It is not of this place. For scientists, this was electrifying. Each interstellar visitor is a time capsule, carrying within it clues about how planets and stars formed elsewhere. The dust, the ices, the chemical fingerprints embedded inside are unlike anything born in our system. Studying them is like receiving a package from another corner of the galaxy. We cannot choose what is inside, but whatever it carries is a direct sample of alien geology. But beyond the scientific excitement lies something harder to describe, a sense of wonder mixed with unease. We like to think of our solar system as home, a bubble where the familiar rules apply. An interstellar object shatters that illusion. It reminds us that the galaxy is not empty, that debris from ancient worlds drifts between the stars, and that some of it brushes past us without warning. Most are harmless, like this one, but the idea alone unsettles. The universe is not static, it is restless, and sometimes its restlessness reaches us. The name Atlas reflects the telescope that found it, yet it also carries mythological weight. In Greek legend, Atlas was the titan condemned to hold up the heavens. How fitting that this visitor, bearing the same name, seems to carry the heaven's secrets on its long journey. Its full designation, 3I/Atlas, is dry on the surface, but hidden in those letters is a remarkable truth. It is only the third time humanity has confirmed such an encounter. To live in an age when these events can be witnessed is a reminder of both our fragility and our progress. As the news spread, astronomers rushed to measure every detail they could. The object was faint, but with large telescopes, its brightness could be tracked, night after night. Instruments looked not only at its motion, but at the halo of gas and dust surrounding it, the coma, that revealed it was a comet. Each observation added a brushstroke to the picture, the speed, the direction, the chemistry, and yet each answer brought new questions. For those listening tonight, perhaps you can close your eyes and imagine the path this visitor has taken. Long before humans walked the Earth, long before Earth itself even formed, chunks of rock and ice were being thrown from young planetary systems around other stars. Gravity slingshot them into interstellar space, where they drifted for eons, untouched, unchanged, waiting. One of those fragments became 3I/Atlas. Its journey through the galaxy may have lasted billions of years, carrying it past stars we cannot name, through clouds of dust and regions of darkness so deep that light barely passes. And now, after all that time, it happens to pass close enough for us to see. That chance alignment is almost poetic. The galaxy is vast, with trillions of objects scattered across its span. The idea that one, launched ages ago from a distant system, should cross paths with our fragile planet in this fleeting moment feels improbable. And yet, here it is, a reminder that the universe is more connected than we realize. For most people on Earth, the event passed unnoticed. The object is too faint to see with the naked eye, too distant to affect daily life. But for those who follow the skies, its presence is profound. It shows us that our solar system is not isolated. We live in a stream of cosmic traffic, even if most of it passes silently by. Each interstellar visitor broadens our understanding of what lies beyond the sun's light. The discovery of 3I/Atlas in 2025 will not be remembered with the drama of a disaster or the spectacle of a comet blazing across the sky. Instead, it is remembered for what it represents, a window into the wider universe. It is a reminder that beyond the familiar planets and moons we know, there are countless other systems, each shaping debris that may one day wander close. The fact that we can see them at all is a triumph of human curiosity. And so, as we begin this story, you may simply let yourself relax. You don't need to hold on to every number or every date. Instead, picture the image of a speck of light recorded on a summer night in Chile, a dot so faint it could easily have been missed, yet carrying within it a history that predates our world. From that single dot, an entire story unfolds, a story of distance, of time, and of our connection to the stars. When scientists first plotted the path of 3I/Atlas, the shape of its orbit spoke louder than any headline could. It wasn't a circle like the planets. It wasn't even an ellipse like the comets that return after decades or centuries. Its path was something else entirely, a hyperbola, a curve that brushes close to the sun and then sweeps back outward, never to return. To picture this, imagine drawing with a pencil around a candle placed at the center of your page. Most comets trace stretched loops, spiraling back again and again, held forever by the candle's pull. But if you throw the pencil line too fast and too wide, it won't close into a loop. It will form an open curve that keeps going. That open curve is a hyperbola. It means the object is not trapped by the sun's gravity. Instead, it will visit once and then leave, vanishing into the dark without a second glance. For astronomers, eccentricity, The measure of how stretched an orbit is the key number. A circle has an eccentricity of 0, ellipses fall somewhere between 0 and 1, but anything above 1 means freedom. The numbers for 3I/Atlas put it comfortably beyond that boundary. In other words, even the Sun, with all its immense gravity, could not hold it. This is a humbling thought. The Sun commands every planet, moon, asteroid, and comet in our system, shaping their paths as a conductor shapes music. And yet, here is an object so fast, so determined, that it bends only slightly to the Sun's will before continuing on its way. For billions of years, it may have wandered through interstellar space, untouched by any star's command, waiting until chance brought it across our field of view. The distances it has traveled are beyond human imagination. The nearest star to us, Proxima Centauri, is over 4 light-years away, more than 25 trillion miles. If 3I/Atlas came from even that close, it would still have drifted for millions of years to get here. More likely, it came from far farther away, launched from the outskirts of some distant star system long before Earth was born. Perhaps it circled a young star that flickered and died. Perhaps it was flung outward by the gravitational pull of a giant planet, ejected violently into the void. However it began, it has spent uncounted ages adrift, moving silently through the cold between suns. Try to imagine that journey. No light to warm it, no planet to greet it. Just endless night, dust, and occasional stars glowing faintly in the distance. Centuries pass in silence. Then millennia. Then eons. Galaxies turn slowly like whirlpools of light, but to this tiny fragment, time has no meaning. It simply travels, pulled by nothing, guided by inertia alone. And after all that time, it happens to cross our skies in 2025, observed by a species that has only recently learned how to look. The very fact that we can see it is a reminder of our progress. Only a few generations ago, the idea of detecting an object this faint and far away would have seemed impossible. Now, with powerful telescopes, we can not only find it but track its path with precision. We can predict exactly when it will reach its closest point to the Sun, exactly when it will slip away again. For an object that has roamed for billions of years, our glimpse is brief, just a few months of visibility before it disappears once more. Yet in that short time, we learn about a journey older than our planet. What makes it even more extraordinary is that such journeys are not rare in the galaxy. Every star system, during its violent youth, ejects countless fragments. Planets form from swirling disks of dust and gas, colliding, merging, and scattering debris. Some pieces fall inward toward the star, others collide and shatter, but many are flung outward, accelerated until they break free entirely. These become interstellar wanderers, billions upon billions of them, drifting forever between the stars. We suspect that space is filled with such objects, but until recently they were invisible to us. 3I/Atlas is a reminder of just how much is out there, unseen. And yet, knowing this does not diminish its wonder. Instead, it deepens it. To look at a faint comet through a telescope and realize it was formed in another star system is like holding a seashell and knowing it came from an ocean on the far side of the world. Its surface, its chemistry, even its dust carry the fingerprint of a place we will never visit. By studying it, we gain knowledge not just of one comet, but of the wider galaxy. Consider this. The solar system is about 4.6 billion years old. Earth formed soon after, and life began within its first billion years. If 3I/Atlas is truly from the thick disk of the Milky Way, as some scientists suspect, then it could predate all of this. It could have formed around a star that lived and died before our Sun even ignited. In its core may lie minerals crystallized in environments utterly unlike those of our solar system. In its ices may be trapped gases that speak of conditions in alien birth clouds. In this way, 3I/Atlas is a messenger not only from afar, but from an era we can barely imagine. The hyperbolic path also carries a subtle poetry. It is the curve of a traveler with no home. Unlike periodic comets, which swing back again and again like pendulums, this one drifts on endlessly. Its story is not of return, but of passage. For humans, who measure time in cycles, years, seasons, orbits. Such a path feels alien. But for the galaxy, it is natural. The universe is full of one-way journeys. Stars live and die. Light leaves its source and never returns. Even galaxies drift apart, carried by cosmic expansion. In this sense, 3I/Atlas mirrors the larger truth. The universe is a place of movement, not permanence. To follow its path with our instruments is to witness a fraction of that endless motion. We watch as it accelerates toward the sun, reaching perihelion, its closest point, before swinging back out. We calculate its speed, more than 130,000 miles per hour, and marvel at its endurance. How has it survived collisions with dust and radiation in the interstellar void? How has a body perhaps less than a kilometer wide endured billions of years intact? Each observation raises new questions, each question pulling us deeper into the mystery. It is tempting to think of this object as insignificant, just another rock drifting by, but when you consider the distances, the timescales, and the odds of detection, its appearance feels like a rare gift. For billions of years it traveled unseen. For a few months it passes through our reach. Then it will be gone again, slipping into the dark, never to be touched by human eyes. We are, in a sense, its brief audience, and in that encounter, we learn not only about the object itself, but about our place in the cosmos. Perhaps the most humbling thought is this: while we track it with computers, while we debate its origin and speculate about its chemistry, 3I/Atlas continues on. Indifferent, it does not care for our questions. It does not slow to give us answers. Its story is written in stone and ice, a story begun in another system long ago. Our task is only to listen, to catch what fragments we can before it moves on. So as you let these ideas drift through your mind, picture the hyperbolic path not as a line on a graph, but as the shape of eternity, a curve that brushes close and then departs, carrying secrets we will never fully grasp, a journey older than Earth itself, older than the sun, continuing long after we are gone. This is what 3I/Atlas represents. Not a threat, not a spectacle, but a whisper from the deep history of the galaxy. And as it glides outward once more, it leads us into the next chapter of its story. The ways we watch, the instruments we build, and the discoveries waiting in its faint light. Once astronomers knew what they were looking at, the race began to watch the visitor more closely. A discovery alone is not enough. The sky is wide and faint objects slip easily into obscurity. To follow 3I/Atlas meant turning some of the most powerful instruments on Earth and in orbit toward a tiny moving point, faint as a whisper. From Hawaii to Chile, from the deserts of Arizona to observatories in Europe, telescopes swiveled toward the same patch of sky. Each night, astronomers traced the dot against the background stars, measuring how it shifted from hour to hour. The measurements, simple in appearance, carried enormous meaning. Every position recorded, every streak of light across a camera's sensor refined the calculations of its path. In those numbers lay answers to where it came from, how long it would stay, and where it was going next. But telescopes do more than mark positions. They also gather light, spreading it into its colors like a prism. In that rainbow, information hides. The gases surrounding a comet absorb and emit light at specific wavelengths, leaving signatures as distinctive as fingerprints. To the eye, a comet may appear as nothing more than a glowing blur. To a spectrograph, it becomes a storybook written in light. Soon after its discovery, both ground-based instruments and space telescopes joined in. The Hubble Space Telescope turned its gaze, capturing images of the fuzzy envelope around the nucleus. The James Webb Space Telescope, with its infrared sensitivity, looked deeper still, detecting the faint molecular glow invisible to human eyes. Together with radio telescopes on Earth, these instruments formed a global chorus, each contributing notes to the growing picture of the stranger in our skies. What they saw was both familiar and surprising. Like other comets, 3I/Atlas grew a coma, a glowing cloud of gas and dust that forms as sunlight warms its surface. Ices locked inside for eons began to sublimate, turning directly into vapor, carrying dust grains outward with them. To us, the coma appears as a misty halo, sometimes stretching thousands of kilometers wide. It is what makes comets so striking, a signal flare announcing their presence. Yet the details of this coma held puzzles. Instead of being dominated by water vapor, as most comets are, 3I/Atlas showed unusually high levels of carbon dioxide. Spectra captured by Webb in August 2025 revealed that CO2, not water, was driving much of the activity. The ratio of carbon dioxide to water was unlike anything commonly seen in comets from our own system. For scientists, this was electrifying. Chemistry is a window into history. The ratios of gases tell where and how a comet formed. In our solar system, most comets condensed in regions where water ice was plentiful, mixed with smaller amounts of carbon-based gases. But if carbon dioxide dominates, it suggests a very different birthplace, perhaps farther from its parent star, or under colder, more exotic conditions. In other words, the fingerprint of an alien nursery. To make sense of this, think of baking bread. The recipe you use leaves behind a unique flavor, a texture that reveals its ingredients and method. Comets are similar. Each one carries the recipe of its origin, the dust, the ices, the proportions of elements. By tasting, or in this case analyzing the light, scientists can tell which kitchen, which star system the ingredients came from. 3I/Atlas, it seemed, was made in a kitchen unlike our own. The coma also tells us about timing. The fact that it became active while still far from the Sun, more than 3 times the distance from Earth to the Sun, was unusual. Most comets wait until they are closer, warmed enough for water ice to sublimate. But here was a comet already glowing, already shedding mass, long before reaching perihelion. This raised questions. Was its surface layered differently? Was the water trapped beneath crusts while the more volatile carbon dioxide escaped first? Or had cosmic rays and eons of radiation reshaped its surface chemistry, sealing some ices while liberating others? For listeners, the exact mechanics may not matter. What matters is that every wisp of gas, every spectral line recorded by our instruments, is a clue. A faint change in brightness might mean a pocket of ice bursting open. A strange ratio of molecules might mean an environment we never expected. In this way, tiny details become windows into places we cannot see directly. Planetary nurseries orbiting stars long extinguished, conditions that no probe has visited. Histories written billions of years ago. This is the quiet magic of astronomy. We cannot touch 3I/Atlas. We cannot scoop its dust into our hands. And yet, with nothing more than light, we can deduce its secrets. Light, after all, is the one thing the universe cannot hide. It travels across space unimpeded, carrying the imprint of whatever it has passed through. Our telescopes are simply the eyes that learn to read it. As weeks passed after its discovery, a portrait of the comet emerged. Its nucleus was likely small, less than a kilometer across. Its coma, by contrast, stretched thousands of kilometers wide, a fragile bubble of activity around a frozen heart. The dust it released reflected sunlight, giving it the glow captured in photographs. To the public, it looked like many comets before it, a pale smudge against the stars. But to those studying it, each faint line of data was treasure. There is something almost human about this process. We see a stranger in the distance, blurry and indistinct, and we lean forward, trying to discern its features. Bit by bit, with patience, the picture sharpens. But unlike human faces, comets reveal themselves not in expressions but in chemistry, in orbits, in light scattered across millions of kilometers. Watching 3I/Atlas was not just an act of measurement, it was an act of patience, of humility, of listening to what the universe chose to show. And in this patience lies a kind of serenity. Each telescope session is quiet, a long exposure gathering photons that left the comet hours ago. Each data set is another thread woven into the story. The process mirrors the very subject, a slow unfolding, an endurance across time. Just as the comet drifts calmly through space, so too do astronomers wait calmly for its secrets to appear. The more we watched, the more it reminded us that the universe is diverse. Not every comet follows the same script. Some flare dramatically and then fade. Others remain stubbornly faint. Some shed tails of dust, while others glow with ionized gas. 3I/Atlas, with its unusual chemistry, joined this gallery of uniqueness, and with it came the realization that our solar system's recipes are not universal. Out there, around other stars, different conditions, different balances of elements, different histories produce worlds and fragments that defy our expectations. For a listener drifting towards sleep, this may sound abstract, but think of it this way. Every comet is a message in a bottle. The bottle drifts across oceans of space for unimaginable times. When it arrives, we uncork it by studying its light, and inside we find not a letter, but a chemical signature, telling us of its birthplace. 3I/Atlas brought us such a message, and though its words were strange, they were undeniably real. As the nights grew shorter and the comet moved closer to perihelion, the observations became harder. Near the sun, its glow was lost in daylight, its faint signals drowned by the star's brilliance. Yet even in absence, the data already gathered spoke volumes. The story was still being pieced together, but the outline was clear. Here was a fragment born in another world, carrying within it the history of stars and planets we will never see. To watch the stranger was to glimpse the larger truth, that the galaxy is filled with such wanderers, each carrying its own secrets. Most will never come close enough to notice. A few will, and when they do, we will aim our telescopes, we will measure their light, and we will learn. The faint dot discovered in Chile had grown into a story spanning continents, instruments, and minds. And as the data piled up, a deeper question began to stir. If such visitors are common, what else drifts unseen between the stars? What do these fragments truly tell us about the places they came from? And how do we separate what is natural from what might hint at something more? Astronomers are clear, 3I/Atlas is not a danger to Earth. Its hyperbolic path guarantees it will never strike our planet. The closest it will come is hundreds of millions of kilometers away, farther than the distance between Earth and Mars at their nearest approach. Calculations are precise, checked again and again by observatories across the world. The numbers leave little room for doubt. In this case, the sky holds no threat. And yet, the human mind rarely rests so easily. Even when scientists explain the safety, many still feel the quiet tug of a question. But what if? We are a species that has always looked upward with both awe and anxiety. The beauty of comets and the mystery of meteors carry a shadow, the awareness that sometimes the heavens do more than inspire. They collide. That awareness is not superstition, it is history. Earth bears the scars of countless impacts, from craters pocking its surface to mass extinctions buried in stone. These events remind us that, though rare, cosmic collisions have shaped life itself. So when an unfamiliar visitor like 3I/Atlas appears, people instinctively reach back to those memories, wondering whether the past could repeat. The most famous reminder lies not in living memory, but in the fossils of dinosaurs. 66 million years ago, an asteroid roughly 10 kilometers wide struck near what is now the Yucatan Peninsula in Mexico. The impact created the Chicxulub crater, more than 150 kilometers across, and unleashed devastation on a planetary scale. The shockwave flattened forests, tsunamis swept across oceans, and a cloud of dust and sulfur blotted out the sun for years. Photosynthesis collapsed, food chains crumbled, and nearly 3/4 of Earth's species vanished. The age of dinosaurs ended, and with it came the rise of mammals, including, much later, humans. That single event is the ultimate echo when we ask, what if? It proves that one impact can change the course of life forever. When people hear of a new comet, even one passing safely by, their thoughts drift to that ancient catastrophe. They wonder whether Earth still lives on borrowed time. More recent events, though smaller, are etched more vividly into human memory. In 1908, in the remote Siberian wilderness near the Tunguska River, a fireball exploded in the sky. A fragment of a comet or asteroid, perhaps only 50 to 100 meters across, entered the atmosphere and detonated in a massive airburst. The explosion flattened 2,000 square kilometers of forest. Trees toppled like matchsticks in every direction, their trunks pointing outward from the blast's center. Because the region was sparsely populated, few people witnessed it directly. Reports from villagers described a sudden flash brighter than the sun, followed by a shock wave that shattered windows and knocked people from their feet. Even thousands of kilometers away in Europe, instruments recorded the atmospheric disturbance. For days afterward, skies across the world glowed with strange lights as dust spread through the atmosphere. If the Tunguska object had arrived just hours later, over a major city instead of wilderness, history might have recorded a disaster of terrible scale. The Tunguska event lingers in the imagination precisely because it shows how close Earth can come to catastrophe without it being inevitable. It was not a global extinction, but it was enough to remind us that the cosmos does not need to send giant asteroids to leave its mark. Even modest fragments, traveling at cosmic speeds, release energy measured in megatons of TNT when they strike our atmosphere. Then, in 2013, a smaller but more widely witnessed reminder arrived over Chelyabinsk, Russia. In the clear winter sky, a brilliant fireball streaked across the horizon. Within seconds, it detonated with the force of nearly 500,000 tons of TNT. The blast shattered windows across the city, injuring over 1,000 people with flying glass and debris. Unlike Tunguska, Chelyabinsk occurred in a densely populated area, and videos captured the event from countless angles. For millions around the world, this was the first time they had seen such power unfold in real time. Though no one was killed, the psychological effect was profound. People realized that Earth's atmosphere shields us from countless small impacts, but not always perfectly. Objects tens of meters across can slip through, exploding in midair with devastating results. If the trajectory had been slightly different, the shockwave could have caused far worse destruction. These stories, Chicxulub, Tunguska, Chelyabinsk, form the backdrop against which every new visitor is judged. When astronomers say 3I/Atlas is safe, they are speaking from careful calculations. But when people hear the word comet, they recall these echoes of the past. The mind leaps from data to drama, from assurance to anxiety. The question, what if, is not irrational. It is the product of memory, of an instinct shaped by survival in a dangerous cosmos. It is also worth remembering that Earth has been struck countless times beyond these well-known examples. The moon's surface, pitted with craters, is a record of what our planet also endured. On Earth, erosion and tectonics erase many scars, but some remain. Meteor crater in Arizona, nearly a kilometer wide. The Vredefort Dome in South Africa, over 300 kilometers across, created 2 billion years ago. Each one tells of collisions that once shook the ground and sky. Astronomers remind us that such events are rare on human timescales. Large impacts, like Chicxulub, occur perhaps once every tens of millions of years. Tunguska-sized events are expected every few centuries. Smaller meteors burn harmlessly in the atmosphere every day, unnoticed. Statistically, 3I/Atlas is not our enemy. But statistics rarely soothe the imagination. We are not comforted by probability. We are moved by stories. That is why the safe trajectory of 3I/Atlas matters less in people's minds than the possibilities it awakens. When you hear that a fragment from another star system is flying through our neighborhood, it is natural to picture disaster. It is natural to remember forests flattened, cities shaken, and species erased. The echoes of past impacts linger like shadows, shaping how we respond to each new object. And yet, there is also perspective. Each of those events, dramatic as they are, is separated by long stretches of time. Earth has endured billions of years of bombardment and still sustains life. The sky is not constantly falling. Instead, these rare encounters remind us of our vulnerability, while also deepening our appreciation for the fragile stability we enjoy. They are reasons for vigilance, not panic. So when scientists assure us that 3I/Atlas will pass safely, we can trust the numbers, but we can also understand why the heart still asks, what if? For in that question lies not only fear, but recognition of the power above us, the power that shaped our past and may one day shape our future again. To this point, we have listened to the calm voices of astronomers assuring us that 3I/Atlas is on a safe course. And indeed, the mathematics leaves no room for doubt. Yet curiosity has a way of wandering into the spaces beyond certainty. If the path were different, if chance or unseen forces nudged it toward us, what story might unfold? Not as a prediction, not as a warning, but as an exercise in imagination. Picture, for a moment, the arrival of a body several hundred meters wide, perhaps larger. It has drifted across the galaxy for uncounted ages, and now its course intersects with Earth. Long before the strike, we would see it glowing in the night sky, a moving star with a halo of gas. Telescopes would track it tirelessly, headlines would speak of little else, and humanity would find itself caught between fascination and dread. But let us step past that, into the vision of what an impact might actually look like. The outcome depends entirely on where it lands. Earth's surface is varied. Land, ocean, and ice each respond in different ways. To understand the possibilities, we must walk through each one in turn. Imagine the object striking solid ground. In the final seconds, the comet would blaze across the atmosphere, brighter than the sun, trailing fire and a roaring shockwave. Traveling at tens of kilometers per second, it would compress the air before it with such force that the atmosphere itself would glow white hot. The last few moments would be a cascade of heat and light, seen across continents. When it struck the ground, the energy released would dwarf the largest nuclear weapons ever built. Even a body less than a kilometer wide could unleash millions of times the power of Hiroshima. The Earth's crust at the impact site would melt instantly, vaporized into a plume that rises high into the sky. A crater several kilometers wide would appear in seconds, surrounded by rings of shattered rock. The shock wave would flatten everything for hundreds of kilometers around. Forests splintered, cities erased. But the destruction would not stop at the edge of the crater. The heat of re-entry would ignite fires across vast distances. Dust and debris hurled into the atmosphere would begin to circle the globe, darkening the sky. Crops would wither without sunlight, ecosystems would strain, and human societies would be tested as never before. And yet, the story would not be one of instant annihilation. Humanity is spread across the globe, and even in the face of enormous catastrophe, survival would continue. The Earth has endured countless such impacts before. Each one feels overwhelming in the telling, but life persists, adapting, reshaping, carrying on. Now imagine a different outcome. The comet strikes water. Oceans cover more than 2/3 of our planet, making this the most likely scenario. At first, the sight would seem no less dramatic. A blazing descent, an explosion brighter than any sunrise. But instead of carving rock, the object would hurl itself into the sea. The result would be waves of unimaginable size. The impact would displace billions of tons of water in an instant, sending walls of ocean racing outward. Tsunamis hundreds of meters high could rush toward coasts thousands of kilometers away. Entire shorelines would be reshaped, cities swept aside, harbors swallowed whole. The roar of the sea would replace the crack of rock, but the devastation would be no less. Beneath the surface, superheated steam would erupt, boiling water into the sky. Salt and vapor would rise into the upper atmosphere, altering weather patterns, seeding clouds, and perhaps cooling the climate for years. Ocean life, from the smallest plankton to the largest whales, would face sudden upheaval. And yet, for all its drama, the ocean also absorbs. Water softens the blow, distributing the energy more widely. The land may be scarred by tsunamis, but the deep sea swallows the crater itself. Unlike a land strike which leaves scars lasting for millions of years, an ocean impact hides its wound beneath restless waves. There is a third possibility, that such an object might strike a polar cap, the frozen expanses of Greenland or Antarctica. Here, the surface is neither rock nor water, but a sheet of ancient ice, kilometers thick. The collision would be spectacular, a flash against white landscapes, a crater punched into the frozen crust. The heat would melt vast quantities of ice in seconds, releasing torrents of water. The impact might destabilize glaciers, sending rivers of ice toward the sea. Over time, this would raise global sea levels, reshaping coastlines in a slower but enduring way. The atmosphere, too, would feel the change. Dust from shattered ice and rock would spread on the winds. The reflection of sunlight, normally bright over white surfaces, would dim as meltwater spread. Climate systems, delicately balanced, would shift in response. Of the three scenarios, this one carries subtler dangers. The immediate devastation would be smaller than a land strike, less dramatic than an ocean wave, but the long-term effects on climate and sea levels could ripple across centuries, altering the world in ways less visible but equally profound. Whichever surface it met, the lesson would be the same. The universe holds a power far beyond anything humanity can match. These objects are small on cosmic scales, mere fragments measured in kilometers at most. Yet their energy rivals the forces that shape continents. They are reminders of how fragile the surface of our world can be, how thin the boundary is between stability and upheaval. Still, to imagine these impacts is not to live in fear. It is to acknowledge the scale of the cosmos, to place ourselves within it with honesty. Earth has always been part of this exchange, from the craters of the moon to the scars hidden beneath our oceans. The story of impacts is woven into the story of life. Without them, we might not even exist. The extinction of the dinosaurs, catastrophic as it was, opened the path for mammals to thrive. Out of destruction came renewal, and out of renewal came us. So when we let our thoughts drift to the possibility of 3I/Atlas colliding with Earth, we are not predicting doom. We are simply listening to the echoes of what has been and imagining the scales on which the universe operates. These visions are not meant to frighten, but to expand perspective, to remind us that even in fragility, life continues. And if we return now to the reality that 3I/Atlas will pass safely by, at distances vast and harmless, the imagination settles back into calm. The visitor is not an agent of destruction. It is a messenger of possibility, carrying with it the knowledge that while the universe is powerful, it is also generous enough to let us simply watch and wonder. For weeks, telescopes watched 3I/Atlas with steady patience, gathering data point by point. The consensus among scientists was clear. It is a comet born of natural processes behaving largely as expected. And yet, around the edges of those certainties, another kind of conversation began to take shape. A quieter, more daring question. What if visitors like this are not always just comets? The thought may sound fanciful at first. After all, rocks and ice are plentiful in the galaxy, ejected by young star systems as they form. Billions must drift through the interstellar dark, and we would expect to see some of them eventually. That is the safe, familiar explanation. But every so often, nature presents something that does not quite fit the mold. And in those moments, imagination steps forward. The clearest example came in 2017, with the discovery of Oumuamua. It was the first confirmed interstellar object ever observed, and from the start it defied expectations. Astronomers tracking it noticed its brightness change dramatically as it tumbled, suggesting an elongated, possibly cigar-like shape. Unlike any asteroid or comet seen before, it reflected light in strange ways, and most puzzling of all, it showed a small but measurable acceleration, as though something were gently pushing it away from the sun. Normally, such acceleration comes from outgassing, jets of gas released as ice warms, providing a tiny thrust. But in this case, no such jets were detected. The object did not grow a coma or tail as comets usually do. It simply moved in ways that left scientists scratching their heads. For many, the most likely explanation remained natural. Perhaps Oumuamua was covered with a thin layer of insulating crust that hid its gas release. Or perhaps it was made of material unlike the comets we know. But for others, the oddities opened the door to speculation. One hypothesis, bold and controversial, suggested that Oumuamua might be a probe, an artificial object, perhaps a fragment of alien technology sent intentionally or drifting as debris. This idea was not proposed by dreamers alone. Avi Loeb, a respected astrophysicist from Harvard, argued that the simplest explanation for its unusual motion might be artificial origin. He suggested it could be a thin sheet, like a light sail, pushed not by engines but by radiation from the sun. Such technology is within our own imagination. Projects like Breakthrough Starshot already explore the idea of sending tiny probes between stars using sails of light. If we can conceive it, might another civilization have done it long before us? The debate was fierce. Many astronomers criticized the claim, pointing out that extraordinary ideas require extraordinary evidence, and none had been found. Yet the possibility could not be entirely dismissed. The mystery of Oumuamua remains unsolved to this day. This is where the whispers begin. When an interstellar object appears, people remember Oumuamua. They recall that first strange visitor, moving in ways we did not fully understand. And so with 3I/Atlas, the question returns, what if not all such visitors are simple fragments of rock? What if, among the natural debris, there are outliers, objects shaped or guided for purposes we cannot yet perceive? Science proceeds cautiously, bound to what can be measured and tested, but human imagination flows more freely. It asks, if we were an ancient civilization sending probes to explore the galaxy, how would we disguise them? Perhaps as comets, indistinguishable from the countless icy wanderers already drifting in space. Perhaps their true systems remain hidden until triggered by a star's warmth. Perhaps their signals are subtle, quiet enough to be lost in the natural noise of the cosmos. Such thoughts walk the line between speculation and science fiction, and yet they persist because they resonate with deeper truths. Humanity has always wondered whether it is alone. Every flicker in the night sky, every anomaly invites that question. Could the universe already be whispering to us, not through radio signals or dramatic encounters, but through the quiet passage of objects we assume are ordinary? At the same time, we must remember how often the extraordinary reduces to the ordinary once studied closely. Many mysteries in astronomy begin with excitement and end with simpler explanations. An unusual orbit becomes the result of gravitational nudges. A strange glow turns out to be dust. A puzzling spectrum reveals chemistry we had not considered. Nature is inventive enough to surprise us without needing intention, and so we are caught between two modes of thought. On one side is the discipline of science, careful and restrained, demanding evidence. On the other side is the pull of imagination, daring to ask what evidence might never confirm, but what our minds long to explore. The whispers of other worlds live in that space between. In the case of 3I/Atlas, all current observations point to natural origins. Its coma, its chemistry, its trajectory, all consistent with an interstellar comet. But its very presence, following in the footsteps of Oumuamua, keeps the door open. We now know the galaxy sends us messengers. And sometimes those messengers carry puzzles. The thin line between science and imagination is not a weakness, it is a dialogue. Science provides the grounding, ensuring we do not leap too far into fantasy. Imagination ensures we do not close the door too soon, that we remain open to possibilities beyond what our instruments can yet prove. Together, they keep us both cautious and curious. As you let this thought drift, picture the sky not just as a backdrop of stars, but as a canvas alive with travelers. Most are simple, yes, rocks, ice, dust. But among them perhaps a few are more, we do not yet know. And maybe that is the real gift of objects like 3I/Atlas, not the certainty they provide, but the questions they awaken. When ancient people watched comets drift across the night sky, they often saw them as messages from gods or warnings of change. Today, our language is different, our instruments sharper, yet the image of comets as messengers still holds power. Only now, the message we imagine they carry is not of doom, but of possibility. The possibility of life itself. Scientists call this idea panspermia, a simple word with an enormous suggestion that the seeds of life are scattered across the cosmos, traveling on rocks, ice, and dust. If this is true, then comets are not only wanderers but couriers, quietly linking worlds together. To understand this, we start with the ingredients. Life on Earth is built from carbon compounds, simple molecules that can join into complex chains, amino acids which assemble into proteins, sugars which form part of DNA and RNA, fatty molecules which create cell membranes. These are not rare in space. They have been detected in molecular clouds, in meteorites, even in the coma of comets. Laboratories on Earth have tested this, simulating the conditions of space. When ice mixed with carbon is exposed to ultraviolet radiation, the kind that streams from stars, amino acids form naturally. The lesson is clear: space is not empty, but fertile, full of chemistry waiting to combine. Comets make excellent containers for this chemistry. Their icy interiors protect fragile molecules from harsh radiation. Layers of dust shield them further, keeping their cores stable for billions of years. Inside, the chemistry of long-gone star systems remains preserved, like time capsules adrift in the dark. On Earth, some of our strongest clues come from meteorites, fragments of ancient bodies that survived their fall. Many contain amino acids, even sugars, and nitrogen-bearing compounds. These finds tell us that complex chemistry can survive the journey through space and atmosphere. If these ingredients reached Earth, then it is possible they also reached other planets, moons, or even young star systems where life later took hold. Comets may have played a special role in Earth's own beginning. In the early days, 4 billion years ago, our planet was bombarded by countless impacts. Water, carbon compounds, and organics may have arrived with those strikes. Out of that chaos, something remarkable happened. Chemistry became biology. We do not know the exact pathway, but we know that life appeared soon after the bombardment slowed. It is tempting to imagine that comets had a hand in sowing the first seeds. From this perspective, 3I/Atlas becomes more than a curiosity. It is part of a grand pattern, the steady rain of wanderers that may spread life's ingredients from star to star. Within its frozen nucleus could lie chemistry formed in a stellar nursery long before Earth existed. If it were ever to collide with another world, it could scatter those molecules once again, giving new ground the chance to grow something alive. The idea stretches the imagination, life not confined to a single planet, but connected across the galaxy, like sparks carried by the wind. One world ignites, then another, each flame fueled by material delivered from elsewhere. If panspermia is real, then life is not an isolated miracle, but a natural outcome of the universe itself. Of course, the theory has limits. Molecules may travel easily, but full living organisms are fragile. Radiation, cold, and time destroy them quickly. Yet even so, experiments on Earth have shown that some microbes can survive extreme conditions. Vacuum, heat, radiation. Tardigrades, tiny water bears, have endured the vacuum of space in laboratory tests. If such resilience exists here, it raises the question of whether some forms of life might endure journeys between stars, hidden deep inside protective rock or ice. Even if living cells do not survive, the chemistry itself may be enough. Once delivered, the molecules can act as raw material for whatever processes take place on their new world. The recipe need not be complete, just enough ingredients to tilt the balance toward life. Other evidence comes from missions like Rosetta, which studied Comet 67P/Churyumov-Gerasimenko. Instruments detected amino acids, such as glycine and even phosphorus, vital for DNA and membranes. NASA's Stardust mission, which returned particles from Comet Wild 2, found organic compounds as well. Each mission adds another piece to the puzzle. Comets are rich in the chemistry that life requires. And so, when we watch 3I/Atlas, we are not only watching a rock, we are watching a messenger of possibility. Its coma, rich with gases and dust, is not only a display of beauty, but perhaps a release of ancient chemistry that has waited billions of years to see another star. What does this mean for us? At the simplest level, it reminds us that we may not be alone in origin. The atoms and molecules that built us may be kin to those drifting now through space, awaiting another landing, another spark. If comets are indeed messengers of life, then the universe may be less divided, less solitary than it seems. We may be part of a shared story, written not on one world but on many. For those drifting towards sleep, there is comfort in this thought. The cosmos, often imagined as cold and empty, may also be generous, scattering chemistry like a farmer casting seeds across a wide field. Not every seed takes root, but some do, and when they do, they blossom into forests, oceans, creatures, and minds that look back into the sky, wondering where it all began. Perhaps 3I/Atlas carries such seed. Perhaps it does not. But its presence alone invites us to reflect on that larger possibility, that life may not be an isolated flame, but a fire kindled again and again, across distances too vast for us to measure. The human eye is drawn to patterns. It is one of our oldest survival skills. To notice the outline of a predator in tall grass, or the rhythm of seasons in the turning of leaves, meant the difference between life and death. We evolved to connect dots, to find shape and meaning even where none may exist. This instinct did not fade as we moved indoors and built cities. It remains alive and insistent whenever we look at the night sky. The stars seem fixed, yet they form constellations that we imagine as hunters, bears, and serpents. The planets wander against that backdrop, and we trace their motions as if they tell a story. Comets flare across the heavens, and we wonder what message they bring. Science has taught us that comets are natural, fragments of ice and rock tracing elliptical or hyperbolic paths. Their tails form not from intention, but from sunlight warming frozen surfaces. Yet when one appears, it is difficult not to feel something more. Our ancestors saw omens of war or famine. Today, even with data in hand, we may still feel unease. The question lingers, is it just coincidence? Or is there some hidden purpose? Psychologists call this tendency apophenia, the mind's habit of perceiving meaningful connections in random data. It is the reason we see faces in clouds or hear words in static noise. In the sky, it becomes a canvas for projection. The regular paths of planets become astrological signs. The sudden arrival of a comet becomes a portent. Even in modern times, the same instinct remains, only cloaked in different language. Why does this happen? Partly because uncertainty is uncomfortable. When faced with the unknown, humans prefer a story, even if invented, to silence. A comet without meaning is simply a rock. But a comet as a messenger, whether of gods or fate, gives us something to hold on to. It becomes part of a narrative we can place ourselves within. Astronomy has advanced far enough to explain much of what we see. We can calculate orbits with precision, predict eclipses centuries in advance, and know with confidence that 3I/Atlas will pass us harmlessly by. Yet knowledge does not silence imagination, instead it reshapes it. Where once we saw divine wrath, now we wonder about alien technology. Where once we feared famine, now we speculate about panspermia. The impulse is the same, to ascribe meaning to what otherwise feels indifferent. History is rich with examples. In 1066, a bright comet appeared in the sky, now known as Halley's Comet. The English saw it as an omen of disaster, and soon after, William the Conqueror invaded, altering the fate of a kingdom. In 1456, another appearance of Halley's Comet led Pope Calixtus III to call for prayers against it, as if warding off a celestial enemy. The comet did nothing but follow its orbit, yet human stories gave it agency. Even in recent centuries, comets have stirred the imagination. In 1910, when Halley's Comet returned, newspapers spread panic that its tail contained poisonous gases. Some people sealed their homes. Others bought comet pills, sold by opportunists. Science knew there was no danger, but fear and meaning outpaced fact. This interplay between knowledge and imagination continues today, with Oumuamua, The first interstellar visitor, debates about its strange motion led some to consider alien technology. With 3I/Atlas, even as telescopes confirm its natural behavior, whispers of intention linger. The thin line between sign and coincidence remains. There is something deeply human in this. We do not simply observe the universe, we interpret it. The sky is a mirror in which we project our hopes, fears, and questions. When we search for patterns in the movements of the heavens, we are also searching for our place within them. And perhaps that is not entirely misguided. While comets and asteroids may not carry deliberate messages, they do carry truths. Their chemistry tells us of other star systems. Their orbits remind us of the violence that shaped planets. Their very presence whispers of connections across the galaxy. In that sense, they are signs, not of fate, but of physics, of history, of possibility. The challenge is to hold both views at once. The discipline of science, which anchors us in evidence, and the openness of imagination, which allows us to see meaning beyond numbers. Together, they enrich our experience of the cosmos. A comet may be coincidence, but it can also be inspiration. When you look at the sky and wonder whether its patterns are signs, you are participating in an ancient habit, shared by every generation before. The stars themselves may not speak, but our minds create stories that give them voice. And in those stories, we find comfort, perspective, and sometimes the courage to face the unknown. As 3I/Atlas drifts on, its path is clear, its chemistry natural, yet for us, it is more than ice and dust. It is another reminder of how deeply we long for connection, how ready we are to see purpose in the vast silence of space. That longing may not change the comet, but it changes us and shapes the way we meet the mysteries still hidden beyond sight. In the weeks when 3I/Atlas draws nearest to the sun, something curious happens. Just when the comet becomes most active, releasing gas and dust in the full warmth of sunlight, it slips from view. The very star that illuminates it also blinds us to its presence. From Earth, the glare of the sun drowns it out completely, and for a time the comet vanishes into brightness. This is not unusual. Many comets pass through this hidden window when they reach perihelion, their closest point to the sun. For astronomers, it is both frustrating and humbling. Instruments on Earth cannot see through the sun's brilliance. Even our most advanced telescopes must wait until the object moves again into darker skies. For a brief interval, we know it is there, but we cannot watch. There is something poetic about this. At the moment of greatest change, when ice sublimates and tails grow brightest, the visitor is hidden. We are left to imagine what it looks like, to predict with models what its activity may be. But the truth remains unseen. Our instruments can do much, but not everything. This limitation is not only about glare. It reflects a larger truth about astronomy, that much of the universe lies beyond our direct vision. Telescopes give us extraordinary reach, capturing light across the spectrum, from radio waves to gamma rays. Yet every tool has limits. Some regions of space remain veiled by dust, some signals are too faint to detect, and some events happen in moments when we simply cannot watch. With comets like 3I/Atlas, these blind spots leave room for imagination. What happens to its surface as it warms? Does it fracture, releasing hidden material? Does its chemistry change in ways we cannot measure from afar? Perhaps nothing unusual occurs at all, but because we cannot see, the door to speculation remains open. In a sense, astronomy is a science of shadows. We rarely touch what we study. Instead, we watch faint signals of light, tiny shifts in position, subtle fingerprints in spectra. From those hints, we build entire stories of stars, planets, and galaxies. It is a triumph of inference, but also a reminder of how little we truly see directly. Consider exoplanets, worlds orbiting other stars. In most cases, we do not see them at all. We infer their presence from the way a star's light dims as a planet crosses in front, or from the wobble of a star tugged by an unseen companion. Entire worlds, oceans, atmospheres, perhaps even life, hidden from sight. And yet, from faint shadows, we learn they exist. So too with comets. The coma of 3I/Atlas glows faintly, revealing gases released by solar heating. Spectra tell us that carbon dioxide dominates its chemistry, but this knowledge comes from slivers of light analyzed carefully. The nucleus itself remains unseen, hidden inside its own cloud of dust and gas. Even the most powerful space telescopes cannot pierce that shroud fully. And beyond what telescopes cannot resolve lies what they cannot reach at all. Countless objects drift through the solar system unseen. Small asteroids, fragments of rock, comets without tails. Some are detected only when they streak briefly through the atmosphere, burning as meteors. Others never reveal themselves. This hidden population reminds us how much slips past unnoticed. Astronomers estimate that only a fraction of near-Earth objects above a certain size have been catalogued. The rest remain uncharted, waiting to surprise us. Chelyabinsk, the meteor that exploded over Russia in 2013, was one such surprise. It came from the direction of the sun, hidden in glare, invisible until it arrived. In that sense, 3I/Atlas is unusual not because it is unseen, but because we are watching it all. For every interstellar visitor we detect, countless others must pass by without notice. Space is vast, our instruments small, our attention limited. What we miss may far outnumber what we know. Yet these limitations are not failures, they are reminders of scale. They show us that the universe is larger than our reach, and that mystery is not a flaw but a feature. To live with mystery is to live with humility, to admit that not everything is visible, not everything is measurable, not everything is knowable in our time. And in that humility, there is beauty. The unseen is not empty, it is potential. What lies beyond sight may one day be revealed by new instruments, new missions, new eyes turned skyward. Already, technology pushes the frontier outward. Space telescopes see further than ground-based ones. Planned missions imagine intercepting comets directly, touching what we now only glimpse. The darkness is not a wall but a horizon, inviting us forward. For now though, as 3I/Atlas disappears into the glare, we accept our limits. We imagine the comet's activity, its gases streaming out, its nucleus reshaped by heat. We cannot see it, but we know it is there. And perhaps that act of knowing without seeing is itself part of the wonder, because in truth, much of life is lived this way. We move through uncertainties, guided by partial glimpses, filling the gaps with imagination. The sky mirrors that habit back to us. It gives us visitors that arrive and then vanish, reminding us that not all truths are immediately visible. Not all mysteries meant to be solved at once. 3I/Atlas continues its journey, unseen for a time, hidden in brilliance. When it emerges again, telescopes will resume their work, capturing its fading light as it drifts outward. But the memory of its invisibility will linger, a reminder of how much passes silently above us, just beyond the reach of our eyes. When we turn our attention to 3I/Atlas, we are not only looking at an object passing through our solar system, we are also looking back into a time so ancient that even Earth itself had not yet formed. This interstellar traveler may be billions of years old, a relic from the galaxy's restless youth. To realize this is to feel the weight of time pressing gently against our imagination. Astronomers have traced its orbit and noticed something unusual. Unlike most objects in our neighborhood, which follow the same broad rotation of the Milky Way, 3I/Atlas approaches from a different angle. This misalignment hints that it belongs to an older population of stars and planets, what astronomers call the thick disk of the galaxy. The thick disk is a population that formed when the Milky Way was young, rough, and chaotic. Stars were being born at a furious pace, colliding and scattering matter in every direction. If 3I/Atlas emerged from that era, then it is not just old, it is ancient beyond ordinary comprehension. Earth is 4.5 billion years old. Our sun is only a little older, at 4.6 billion. But the thick disk stretches back nearly twice as far, 8, 9, even 10 billion years. That means this small fragment could have been drifting through space for twice the age of our world. To place it in human terms, imagine compressing Earth's entire history into a single year. Life would appear in early March, dinosaurs would arrive just before Christmas, and humans only in the final minutes of New Year's Eve. In that scale, 3I/Atlas would already have been traveling through space since the previous December, an entire year before our story even began. It is difficult to hold such spans in mind. A billion years is not just a long time, it is a different kind of time, one that dwarfs mountains, continents, even the rise and fall of oceans. Whole mountain ranges can rise and vanish within a few 100 million years. Species evolve, flourish, and disappear in even shorter intervals. Civilizations, the longest any human culture has endured, are but flickers when compared to these scales. Yet 3I/Atlas has endured them all, silently crossing the galaxy, untouched by our histories. How can something so small survive for so long? The answer lies in the nature of comets. A comet is fragile compared to planets or moons, but its isolation also protects it. In deep interstellar space, far from stars, there is almost nothing to erode it, no atmosphere to wear it down, no geological activity to recycle it, no oceans to dissolve it. It simply drifts in darkness, its ices preserved in cold so deep that molecules hardly move. Radiation does strike it, cosmic rays passing through, but the damage is slow, spread across ages. In this way, a comet becomes a time capsule, carrying chemistry from its birth to the present day. The thought that 3I/Atlas may predate Earth is humbling. Our planet feels ancient to us. We measure human history in centuries, planetary history in billions of years, planetary history in billions. But here is an object that was already ancient before the Earth gathered from dust and gas. When the first oceans filled our basins, this traveler was already far from its home. When the first life stirred in those waters, it had already circled the galaxy many times. When the dinosaurs thundered across primeval forests, it was still moving through the void, unseen, unremarked upon. To encounter it now is not chance alone. Countless fragments like this must exist, scattered by violent events in other systems, but only a few wander close enough to be noticed. That we see this one is a matter of timing, of geometry, of our instruments being ready. In its billions of years of travel, this brief crossing of our skies is but an instant. And yet, in that instant, we glimpse a piece of galactic prehistory. The thick disk origin carries more than numbers. It tells a story of a younger galaxy less orderly than today. Back then, stars formed in crowded nurseries, packed so tightly that close encounters were common. When two stars passed near one another, their gravity could scatter comets and asteroids outward, ejecting them into interstellar space. Some were destroyed, some captured by new systems, and some, like 3I/Atlas, set free to wander endlessly. Each is a survivor of ancient turbulence, carrying within it the memory of that era. Astronomers sometimes compare these objects to fossils. Just as fossils preserve traces of ancient life, comets preserve traces of ancient chemistry. Inside 3I/Atlas, locked in frozen ices, may be molecules formed under conditions unlike any in our solar system. Ratios of carbon, nitrogen, or oxygen may hold signatures of stars that lived and died long ago. To sample such material would be to hold a record from before Earth itself existed, a tangible fragment of the universe's deep past. Of course, we cannot yet reach it. We observe from afar, reading its spectra, inferring its properties, but even those faint clues hint at its age. High levels of carbon dioxide, for example, may suggest formation in a colder region than those where most comets in our solar system were born. Its angle of approach, against the general flow of the galaxy, reinforces the sense that it comes from a population that has drifted for billions of years without being tidied into alignment. There is something paradoxical about this. 3I/Atlas is both fragile and enduring, small enough to be hidden in a telescope's field of view, yet strong enough to survive billions of years, vulnerable to breakup if it passes too near a star. yet steady in its persistence across ages. Its very survival shows us that endurance is not always about strength. Sometimes it is about patience, about existing quietly, unchanged, until chance brings you into view. For us, the presence of such an object stretches our perspective. We live by short rhythms, hours, days, seasons. Even when we think in centuries, we are still measuring small things. To consider an object that has drifted for billions of years is to step outside those rhythms. It invites us to see time not as a line of years, but as a vast ocean, with objects like 3I/Atlas as currents moving slowly across it. This is part of the wonder of astronomy. Every observation carries not just distance but duration. Light itself takes time to travel, so that when we look at stars, we see them as they were years, centuries, or millennia ago. With comets like this, we see not just distance, but history embodied in matter. The dust it releases today may have been frozen since before Earth was formed. Each particle is older than our planet's mountains, older than our oceans, older than any life that has ever lived here. To think of this is to feel both small and connected. Small because our world is a newcomer, a brief moment in cosmic history. Connected because fragments like 3I/Atlas remind us that Earth's story is part of a larger one, stretching back before our beginning. The universe is not only vast in space but deep in time, and we live within that depth whether we notice it or not. In the end, 3I/Atlas carries no inscription of its age, no marker of its origin. It drifts silently, giving us only faint clues, but even those clues are enough to remind us that the galaxy holds survivors from eras long gone. They continue to move, patient and unnoticed, until for a moment they pass into view. When we watch them, we are not only studying an object, we are witnessing the endurance of matter across the span of time itself. There is a curious paradox in the way we respond to the universe. On one hand, we crave certainty. We want answers that are clear, predictions that are firm, and explanations that remove doubt. On the other hand, we are irresistibly drawn to what unsettles us, the mysteries, the gaps in knowledge, the questions that cannot yet be answered. Nowhere is this clearer than in the way humans respond to objects like 3I/Atlas. Astronomers tell us it is harmless. The mathematics are solid, the orbit precise. It will pass at a safe distance and continue on its way. Yet despite this reassurance, people wonder, what if? What if the trajectory changes? What if it hides something more? What if its presence means something beyond the physical? These questions, though not supported by the data, carry their own appeal. They allow the imagination to take flight where certainty leaves no room. Psychologists have long studied this pull toward worst-case scenarios. Our brains evolved to anticipate danger, to imagine threats before they arrive. For early humans, this skill increased survival. If you heard a rustle in the grass, it was safer to assume a predator than to dismiss it as wind. Those who imagined the worst often lived long enough to pass on their caution. That instinct remains with us today, even when the threats are cosmic rather than immediate. When we hear of an interstellar object, the instinct awakens. Though the numbers reassure, our minds drift to disaster movies, to ancient extinctions, to possibilities beyond control. Part of us almost prefers the tension because it gives the unknown a shape. A nameless mystery can feel more unsettling than a dramatic but familiar fear. To imagine the worst is to give form to uncertainty, to make it something we can hold. But fear is only part of the story. Alongside it lives wonder. The same imagination that invents worst-case scenarios also creates visions of beauty, possibility, and awe. We look at 3I/Atlas and wonder whether it carries chemistry from distant stars, or whether it has traveled longer than Earth has existed. This kind of speculation comforts us in a different way. It tells us we are part of something vast, that mystery itself can be a source of meaning. There is a gentle balance between the comfort of knowing and the thrill of not knowing. Certainty gives us security. It allows us to plan, to rest, to feel safe. Mystery gives us excitement. It keeps us curious, engaged, awake to possibilities beyond ourselves. Too much certainty can feel dull, too much mystery can feel overwhelming. Between them lies the space where fascination grows. Stories about comets show this balance across cultures. In the past, their sudden appearance in the night sky often inspired dread. Without the tools to predict or explain, people filled the gap with stories of omens and divine will. The fear was real, but so was the wonder. The comet was a sign that the heavens were alive, that something beyond ordinary life was happening. Today, science explains much of what comets are, but the fascination remains. We still gather outside to watch them, still feel a quiet thrill when a new one appears. Worst-case scenarios are not simply exercises in fear. They are also stories we tell ourselves to practice resilience. By imagining disaster, we rehearse how we might respond. We imagine survival, rebuilding, adaptation. Even when the threat is not real, the story serves a purpose. It gives us a safe place to explore our limits, to test our strength against challenges we will never face. At the same time, mystery keeps us humble. When we admit that not everything is known, we accept that the universe is larger than our explanations. That humility does not weaken us, it deepens us. It reminds us that we are part of a cosmos that will always exceed our understanding, that there will always be questions waiting just beyond our reach. 3i/Atlas embodies both sides of this fascination. It reassures us with predictable motion, yet tempts us with questions about its age, its chemistry, its origins. It gives us certainty, safe passage, known trajectory, and at the same time mystery. A fragment older than Earth, carrying secrets from before our planet was born. The combination is powerful. It explains why people stay awake at night, thinking not only of what they know, but of what they cannot know. For those drifting into sleep, this fascination mirrors the mind's own journey. At night, the mind balances between the known and the unknown, the rational and the dreamlike. Thoughts wander, connecting images in new ways. Certainties soften into possibilities. Fears blend with wonder. And the unknown becomes not something to resist, but something to explore. Perhaps this is why cosmic mysteries make such soothing companions for the night. They remind us that uncertainty is not an enemy but a landscape. Worst-case scenarios, far from being only about fear, become invitations to imagine, to see ourselves within stories larger than our daily lives. And mysteries, far from being frustrating, become the very texture of a universe that is never finished, always unfolding. 3i/Atlas will pass on, leaving behind no harm, only the memory of its presence. But in its brief crossing, it stirs in us this double response, the urge to imagine disaster and the quiet pleasure of wonder. Together, they remind us of why we look up at all, not only to find answers, but to lose ourselves for a time in the vastness of questions. Long before telescopes traced orbits or spectrographs measured chemistry, the sky was a theater of meaning. Every star, every wandering planet, every sudden streak of light became part of a story told by human beings who looked upward and searched for signs. Among all celestial visitors, comets stood apart. They appeared without warning, moving strangely compared to the steady stars, leaving trails of fire and smoke. To early eyes, they were not icy fragments obeying physics. They were messages. Omens from the gods, warnings of change, harbingers of fortune or doom. When ancient Babylonian scribes carved symbols into clay tablets, they often noted unusual events in the sky. A comet blazing across the heavens was not recorded simply as a curiosity. It was linked to earthly events. The rise of a king, the fall of a city, the outbreak of war. In this way, the sky became a mirror of politics and fate. People read it as one might read a scroll, interpreting meaning where we today see mathematics. In China, imperial astronomers worked with similar seriousness. To them, the emperor's mandate to rule was granted by heaven, and comets were a language of that higher power. A streak of light across the night might signal that heaven's favor was shifting, that rebellion was near, or that the dynasty was in danger. Court records describe comets in precise detail, their shape, their color, their tails. Some were called broom stars, sweeping away rulers. Others were likened to spears, heralding battle. For emperors, these observations carried real consequences. A comet could force political decisions, religious ceremonies, even military campaigns. The Roman world, too, gave comets great weight. After the assassination of Julius Caesar in 44 BCE, a brilliant comet appeared in the sky during games held in his honor. Romans took it as a sign that Caesar's soul had risen to the heavens, a divine affirmation of his power. Coins were minted with the image of the comet, linking the heavens directly to earthly authority. That single streak of light helped transform a murdered general into a god in the Roman imagination. Centuries later, Halley's Comet became one of the most famous celestial omens in history. Its passage in 1066 was seen as a fiery herald of upheaval. On the Bayeux Tapestry, embroidered to commemorate the Norman conquest of England, the comet is shown blazing overhead as Harold, the last Anglo-Saxon king, loses his crown to William the Conqueror. For those who lived at the time, the comet was not a neutral visitor. It was woven into the story of conquest and change. Throughout the Middle Ages, comets were feared as signs of pestilence and disaster. In 1456, when Halley's Comet returned, Pope Calixtus III ordered prayers and even exorcisms against it, as if the comet itself were an invading force. Though powerless to affect its orbit, the Church sought to defend people spiritually from what they believed it signified. In an age of uncertainty, when plague and war were common, a comet was seen as a celestial reflection of earthly chaos. Yet not all myths were dark. In some cultures, comets were linked to fertility, abundance, or renewal. Polynesian traditions sometimes saw them as navigational markers, guiding explorers across vast oceans. Among certain Native American groups, comets were seen as spirits carrying messages, not always of doom but of transition, reminding people that the world was alive with unseen forces. What unites all these stories is the human impulse to connect the sky with life below. The comet was never just a comet. It was a sign to be interpreted, a piece of a larger conversation between heaven and earth. People needed meaning, and comets offered a blank canvas for imagination and fear. The echoes of these myths still linger, even in the modern age, when we know comets are icy bodies sublimating in sunlight. They stir unease. Newspapers in 1910 sensationalized Halley's Comet, claiming its tail contained poisonous gas that might destroy life on Earth. Some people sealed their homes, others bought comic pills or gas masks. The science was clear, but the ancient reflex to see danger in the sky was stronger. And it has not vanished. When Oumuamua passed through in 2017, speculation ranged from natural rock to alien probe. For 3 Versailles/Atlas, though astronomers assure us it poses no risk, whispers of worst-case scenarios persist. These reactions are not new. They are the continuation of a very old habit, projecting meaning onto what we cannot control. Why do comets inspire such myths? Partly because they break pattern. Stars rise and set in order. Planets move with predictable grace. But comets arrive suddenly, disrupt the familiar sky, and then vanish. They are strangers, and strangers always invite stories. A sudden guest at the edge of vision demands explanation. Our ancestors filled the silence with omens. We, even with data in hand, fill it with speculation. And perhaps there is wisdom in that. The myths remind us that the sky has always been part of human life, not distant but intimate. People feared comets because they mattered. They changed the way leaders acted, the way armies marched, the way people prayed. In their stories, we see not only superstition, but also the power of the imagination to weave the cosmos into human history. Today, when we watch a comet, we may not fear famine or invasion, but we still feel something stir. We still sense the presence of a visitor from beyond, carrying with it the weight of distance and time. And in that sensation, there is a trace of the old myths, the feeling that the heavens are speaking, even if we now translate their language differently. 3I/Atlas is observed with careful instruments, measured in numbers rather than omens, but the very fact that it draws our attention, sparks stories, and awakens questions shows how deep the tradition runs. The myths written in the sky are not gone, they have simply evolved. Where once a comet signaled the fall of kings, now it signals our search for meaning in the unknown. Where once it was an omen of plague, now it is a subject of science fiction and speculation about other civilizations. The canvas remains the same, only the paints have changed. As it drifts across our skies, 3I/Atlas reminds us that comets have always been more than physical. They are mirrors of human thought, reflecting fear, hope, power, and imagination. We may no longer call them broomstars or divine swords, but we still look up and wonder. In that sense, the myths continue, carried forward not in superstition, but in the stories we tell ourselves whenever the heavens surprise us. The story of 3I Atlas is not only about what we see today, it is also about what lies ahead. Every time an interstellar visitor crosses our skies, astronomers are reminded of how much we still cannot do. We can watch, measure, speculate, and model, but we cannot yet reach out and touch. That gap between seeing and holding may be the most powerful motivation for the future of discovery. The first step lies in our eyes on the sky. New telescopes are already changing what we notice. For centuries, comets were discovered by chance, by shepherds, monks, sailors, or stargazers who happened to look up at the right moment. Today, dedicated surveys sweep the heavens night after night, capturing images with automated cameras, searching for faint moving points of light. The Vera C. Rubin Observatory, soon to begin its decade-long sky survey, promises to expand this power dramatically. With its vast mirror and wide field of view, it will scan the entire visible sky every few nights, comparing images to catch changes. For interstellar objects, this is transformative. Instead of luck, we gain routine. Instead of chance encounters, we gain systematic vigilance. Rubin's survey may increase the number of interstellar discoveries from once a decade to once a year. Each detection will come earlier, giving scientists more time to prepare. With early warning, we can point powerful instruments at the visitor, track its behavior from farther out, and perhaps plan missions that intercept rather than just observe. The dream is not just to watch these travelers pass by, but to meet them halfway. Other instruments will sharpen the picture. The James Webb Space Telescope has already shown us the chemical fingerprints of comets with stunning precision. Future space telescopes, designed for even more detailed spectroscopy, may reveal subtle features, isotopes that hint at the star where an object formed, or molecules that suggest processes unknown in our solar system. Radio observatories, from ground arrays to future instruments on the far side of the moon, will listen for the faintest whispers, confirming natural origins, or perhaps surprising us with something stranger. But telescopes, no matter how advanced, will always be limited by distance. To truly understand an interstellar visitor, the dream is to send a spacecraft. Missions have already touched or sampled comets from our own system. ESA's Rosetta landing on 67P/Churyumov-Gerasimenko, NASA's Stardust capturing particles from Wild 2, and OSIRIS-REx bringing back a sample from asteroid Bennu. Each mission showed the power of direct contact, discoveries that no telescope could have made. Imagine applying the same approach to an interstellar object. The challenge is timing. Visitors like 3I Atlas travel fast. By the time we see them, they are already racing past. Designing and launching a spacecraft in that window is nearly impossible. That is why some scientists are working on a bold idea. Keep a probe ready, waiting in space. Instead of rushing after a discovery, we would launch ahead of time, stationing the probe in a location where it can pivot quickly toward the next visitor. With chemical rockets, this is daunting. With advanced propulsion, solar sails, ion engines, or even nuclear-powered concepts, it becomes more realistic. One proposal, called the Comet Interceptor, is already moving forward under the European Space Agency. It is designed to wait in a parking orbit until a suitable target appears, then fly out to meet it. While its first mission may visit a long-period comet from our own system, the principle is the same. If adapted for interstellar visitors, it could one day deliver humanity's first close-up images of an object born around another star. The implications of such a meeting are immense. To hold in our hands a fragment of material from another solar system would be unlike any sample collected before. Meteorites that fall to Earth, while fascinating, all come from within our own system. They tell us about Mars, the Moon, or the asteroid belt. An interstellar sample would tell us about chemistry under an entirely different sun. Its isotopes, its minerals, its ices would be a fingerprint of alien worlds, preserved across billions of years. Think of what such a fragment might reveal. Perhaps its water carries a different balance of hydrogen isotopes, hinting at the temperature of its home star's nursery. Perhaps its carbon compounds show unusual chains, molecules that never formed in our neighborhood. Perhaps it carries noble gases, trapped when its parent system first formed, that speak of conditions long gone. Each clue would expand our picture of the galaxy, turning the abstract idea of other solar systems into tangible matter. Beyond science, there is also something deeply emotional in this dream. Imagine a small container in a laboratory, holding dust collected from an object like 3I Atlas. To know that the grains inside once circled another star, perhaps before Earth even existed, would be to hold a fragment of galactic memory. Students, scientists, and dreamers alike would look at it not just as data, but as a relic, proof that our story is part of a larger one. This dream of contact is not purely technical. It also reflects a timeless human urge, the desire to bridge distance, to close the gap between seeing and touching. When early navigators saw distant islands, they longed to set foot on them. When astronomers glimpsed planets through telescopes, they dreamed of walking their surfaces. Now, when we glimpse interstellar visitors, we imagine holding them in our hands. The progression is natural. Each step draws the universe closer, making the abstract concrete. The future of discovery will also reshape how we think about risk. The better we track interstellar objects, the more confident we become in their harmlessness, and the better we prepare for the rare case when an object might pose danger. Improved surveys will not only fuel curiosity but also protect us. A century ago, humanity had almost no warning of near-Earth objects. Today, we have partial catalogs. Tomorrow, with Rubin and its successors, we may achieve nearly complete coverage. Safety and wonder will advance together. For those drifting into sleep, it is worth reflecting that discovery is not only about instruments and missions, it is about patience. The universe sends visitors in its own time. Sometimes centuries pass between major comets, sometimes decades between interstellar objects. Our role is to be ready, to watch, to prepare. The future of discovery is not a race, but a posture, a willingness to be surprised and the readiness to respond when surprise arrives. And so, as 3 Atlas moves on, astronomers already look ahead. They imagine the next visitor and the one after that. They picture a time when spacecraft lie in wait, when samples from distant stars rest in Earth's laboratories, when each interstellar fragment expands our understanding of the galaxy. The story of discovery does not end with watching a light move across the night sky. It continues, deepening with every new instrument, every new mission, every new fragment that drifts our way. When astronomers chart the orbit of 3I Atlas, they produce curves, coordinates, and numbers precise enough to predict its movement years in advance. The comet itself does not carry emotion. It does not intend to comfort or to alarm. It drifts, indifferent, a fragment of ice and dust obeying gravity and sunlight. Yet when we look at it, what we see is never only the comet. We see ourselves reflected back. Throughout history, every unusual object in the sky has revealed more about human imagination than about celestial mechanics. A blazing comet once told people of kings destined to fall, armies fated to march, or worlds about to end. Today, with equations at hand, we know such tales are not written into the object itself. And still, the old impulse lingers. A visitor like 3I Atlas draws out speculation, fear, hope, and wonder in equal measure. When NASA states clearly that the comet poses no danger, that its path is safe and distant, the numbers are reassuring. But conversation rarely stops there. People begin to ask, what if? What if the orbit shifts? What if its chemistry hides something more? What if its appearance means something beyond the material? None of these questions arise from the object itself. They arise from us. They are projections of curiosity and of unease. In that way, the comet becomes a mirror. It reflects our hunger for meaning, our nervousness in the face of uncertainty, and our tendency to wrap the unknown in stories. There is comfort in certainty, but comfort alone rarely satisfies. We are drawn to mysteries because they stretch us. A comet from another star system pushes the imagination into territories we do not usually travel. It reminds us that Earth is not the only stage. The galaxy itself has corridors and crossroads, and sometimes travelers from those spaces cross into our sight. Faced with that reminder, some minds respond with fear, others with awe, but nearly all with fascination. The way we talk about 3I Atlas says much about how we see ourselves in the universe. For some, the comet inspires dread because it recalls ancient extinctions or imagined invasions. That response highlights our fragility, the awareness that life on Earth is precious but not invulnerable. For others, the comet inspires reverence because it feels like a messenger carrying secrets from beyond. That response highlights our hope, the sense that the universe is not empty, but full of stories waiting to be discovered. Neither response is right or wrong. Both reveal different sides of humanity. Fragility and curiosity, fear and wonder are woven into us. The comet does not create these feelings, it simply gives them a place to land. Consider how quickly stories grow around such visitors. A news article notes the discovery, and soon conversations spread. Could it hit us? Could it be alien? Could it carry life? The details may vary, but the pattern is consistent. We take the raw fact, an object on a hyperbolic path, and add layers of imagination. This is not a flaw in human thinking. It is part of what makes us storytellers, a species that turns raw data into narratives. The comet becomes more than a point of light. It becomes a canvas onto which we paint our deepest questions. This habit can be traced to our earliest days. The stars overhead became constellations, linked into hunters, lions, and queens. The moon became a calendar, a companion, even a deity. Meteor showers became messages. The sky has always been more than physics. It has been a mirror of mind. 3 Atlas belongs to this same tradition. Even as we analyze it with modern tools, we cannot help but ask what it means. In this sense, the comet is a reminder that science and imagination are not opposites, but companions. Science measures what is, while imagination asks what it might mean. Both are ways of engaging with the unknown. When scientists design missions to intercept future interstellar objects, they are using data, but behind that effort lies a dream. The dream of holding alien material, of bridging a distance that once felt impossible. That dream is not numbers alone, it is hope. Hope and fear often run side by side. Fear whispers of collision, extinction, or invasion. Hope whispers of discovery, connection, or understanding. Each visitor from beyond awakens both voices. Which one we listen to may depend less on the comet than on the moment in history. In times of war or uncertainty, comets are read as threats. In times of curiosity and peace, they are seen as gifts. The object itself does not change. We do. That is why 3 Atlas, though physically unremarkable compared to many comets, holds such symbolic power. Its significance lies not in size or brightness, but in its origin. It comes from outside, from another star system. That alone is enough to awaken questions larger than the object itself. To us, it becomes a stand-in for the entire unknown. To reflect on this is to glimpse something about humanity itself. We are small creatures on a small world, yet our minds reach outward, wrapping even distant ice in stories of purpose. Our fragility is real. We cannot stop the passage of comets. We cannot yet intercept them at will. And yet our imagination is equally real. We can see in them the possibility of life spread, the chance of cosmic neighbors, the evidence of worlds we will never touch. In that balance lies a quiet beauty. We are vulnerable, but we are also endlessly curious. We fear, But we also wonder. When a comet like 3I Atlas passes by, it reflects both sides back to us. The cold light on its coma is also a light on our own nature. The mirror is not always flattering. Our tendency to jump to worst-case scenarios reveals anxiety, impatience, sometimes mistrust of knowledge. But it also reveals care. We imagine threats because we value survival. We imagine endings because we treasure what we have. Beneath the fear lies attachment to life, to Earth, to one another. The comet, in reflecting that, shows us what matters most. At the same time, the mirror can be inspiring. Our urge to study, to intercept, to touch, shows the depth of our curiosity. We are not satisfied with reassurance alone. We want to know, to hold, to understand. That drive has carried us from caves to cities, from firelight to satellites, from myths to missions. A single interstellar visitor cannot explain us, but it can reveal the restless hunger that defines us. For those lying in the quiet of night, listening to the story of this comet, the reflection becomes personal. What do you feel when you picture it moving through the dark? Fear? Wonder? A mixture of both? Whatever the answer, it tells you something about yourself, just as it tells us something about humanity as a whole. 3 Atlas is not a message, not a warning, not a blessing. It is a traveler. Yet in its passage we see messages, warnings, and blessings of our own making. The comet reflects not only sunlight but the human mind. To follow it is to follow ourselves, to notice the stories we tell, the hopes we nurture, and the fragility we admit in quiet moments. And so, as it glides beyond our reach, it leaves behind no physical trace on Earth. Its impact is not a crater, but a reflection, a subtle awareness that when we gaze at the unknown, what we often discover is something about ourselves. Imagine standing outside on a cold night, the kind where the sky feels endless and sharp. Above you, countless stars scatter across the dark, and somewhere among them, faint but real, moves 3I Atlas. It does not thunder or blaze across the horizon like a firework. It does not split the heavens in drama. It moves quietly, a small light among larger ones, passing through without fanfare. And yet, to notice it is to feel the brush of something extraordinary. A visitor from beyond, drifting through our corner of the cosmos before vanishing back into the silence. This is the image we return to, a traveler crossing our skies. Not an invader, not a destroyer, not a herald of doom, just a fleeting guest, pausing for the briefest of moments in our presence before moving on. To know this is to feel both wonder and humility. The comet is not ours to keep. It does not belong to Earth, to humanity, or to history. It belongs to the galaxy, to the long story of stars and their fragments, and we are only a chapter it briefly touches. Its path is already written. The equations that describe it are elegant, precise, and uncaring. 3I Atlas will sweep past the sun, glow faintly as its ices respond to warmth, and then slip outward again, following its hyperbolic trajectory into the darkness. Gravity does not hold it here. It is unbound, free to continue on its way long after Earth has turned and forgotten. The sheer simplicity of that motion is what makes it so haunting. While we wonder, speculate, and imagine, the comet itself merely moves. Yet in moving, it leaves an impression. Not in stone or soil, not in craters or debris, but in thought. For those who study it, 3 Atlas becomes a reminder that the galaxy is not empty. For those who hear of it, it becomes a spark for imagination, stirring visions of other stars, other systems, other possibilities. And for those who watch it in the quiet of night, it becomes a moment of connection, fragile, temporary, but deeply real. The fleeting nature of this encounter is what gives it weight. If the comet lingered, if it orbited our sun like any other, it would soon become familiar, another predictable member of the solar family. But because it comes only once, never to return, it carries a sense of rarity that cannot be repeated. Like a traveler passing on a distant road, seen only for a moment before they vanish into the horizon, the beauty lies in its transience. Throughout history, people have sought permanence. Monuments of stone, libraries of words, legacies of power. Yet so often, it is the fleeting things that shape memory most deeply. A melody heard once, a sunset that lingers only minutes. A comet from another star seen only in a season. 3i Atlas joins that category. It teaches us that not all value lies in duration. Sometimes the briefest encounter carries the deepest meaning. In that way, the comet becomes almost dreamlike. Dreams, too, come and go without permanence, leaving behind impressions more than facts. You cannot hold them, but you remember their feeling. Watching 3i/Atlas is similar. You may not recall its exact magnitude or coordinates, but you will remember the thought that for a moment, Earth was host to a guest from far away, a wanderer older than our world itself. Science gives us details, its speed, its size, its chemical quirks. But the lasting impact is not just scientific, it is emotional. It is the feeling of being part of a larger story, of knowing that the universe does not begin or end with us. This is what makes the comet a messenger. It does not bring words or warnings, but presence. It carries the quiet truth that the galaxy is alive with movement, that fragments of other stars pass us by, that we are not isolated in our corner, but connected to a wider web. The farewell it offers is gentle. Unlike the catastrophic collisions that ended ages past, 3i Atlas leaves no scar. Unlike the myths that cast comets as omens of war or plague, it departs without judgment. Its message, if we can call it that, is softer, that the universe moves on vast scales, and we are fortunate to notice when one of its wanderers crosses our path. For astronomers, this farewell is an invitation. The data gathered will be archived, studied, compared, and remembered. Each observation adds to the growing record of interstellar objects, building the foundation for missions yet to come. For dreamers, the farewell is a whisper of possibility, that somewhere out there, other comets are moving, other fragments are waiting, and one day, perhaps, we will be ready to meet them more closely. For everyone else, it may simply be a passing story. A headline glimpsed, a fact remembered faintly. Once, a comet came from another star. That is enough. Not every guest leaves monuments. Sometimes they leave only a memory of their passing, and that memory, though quiet, becomes part of the tapestry of how we see the cosmos. The most fitting way to think of 3i Atlas may be as a messenger not of answers, but of perspective. It does not tell us what lies beyond, but it reminds us that there is a beyond. It does not solve mysteries, but it proves they exist. It is a fragment of something larger, a clue that the galaxy is not empty dust, but a place where countless stories unfold. By passing through, it reminds us to keep looking, to keep wondering, and to keep dreaming. As it fades from view, blending again into the vast dark, the comet does not leave us poorer, it leaves us richer for having noticed, richer for having paused to reflect on time, distance, fragility, and hope, richer for having been reminded that the sky, even in its silence, is alive with visitors. The stars remain where they are, steady points in the deep. Earth continues its orbit, carrying us into new seasons. Life goes on, ordinary and familiar, and somewhere, already, 3i Atlas drifts outward, leaving our sun behind, carrying its secrets farther still. It will not look back. It cannot. But we, having seen it, carry a trace of it forward in thought and memory. In the end, this is its gift, not destruction, not alarm, but presence. A fleeting guest whose passing reminds us of the scale of things, of the brevity of encounters, and of the beauty in simply noticing. In that sense, 3i Atlas fulfills the role of a messenger perfectly. It comes, it stirs reflection, and it moves on, leaving us to dream. And as sleep gathers, the comet drifts in your imagination the way it drifts in space, quiet, steady, unhurried. A light that was here for a moment, now continuing its journey into the dark. A reminder that we, too, are travelers, passing briefly through the vastness, carrying our own stories into the unknown.